Hello everyone. So this is Dr. A. Jaganmohan Reddy. Welcome to your GMR Chemistry Lab. Our today's topic is Bohr's model of atom. To overcome the problems in the Rutherford model, this theory is proposed. Okay, to understand the structure of the Bohr theory, first you have to know what is the basic structure according to Bohr theory. So basic structure of the atom is the total protons and neutrons present at the center of the atom, and it is called a nucleus. So total what it may be, protons and neutrons present in the atom, they are located at the center, it is called a nucleus. And the remaining electrons will be revolves around the nucleus. This is the basic concept of the Bohr theory. All the protons, neutrons present at the center, it is called a nucleus. The nucleus is having the positive charge, and electrons will be revolves around the nucleus in a certain orbits. This is the basic concept. And next let us come to first postulate of the Bohr theory. So according to the Bohr theory, electrons are revolving around the nucleus in a certain orbits. So that means around the nucleus these electrons are revolving, what is that one, in a certain orbits. These orbits are also called shells. So it may be first shell or second shell or third shell, like that. The electrons are revolving around a nucleus in the certain distance in the certain paths. And these paths are called principal quantum number. So where the electron is, what is that one revolving, that is called principal quantum number. And these are denoted as 1, 2, 3 or KLMN. So we may denote that as 1, 2, 3 from the nucleus, or that will be denoted as KLMN. And these orbits are called stationary orbits. So why you are calling it is stationary orbit? So as long as electron is revolving in that orbit, there is no change in the energy of the electron. So it is not gaining the energy or it is not absorbing the energy. That's why it is called a stationary orbit. So why it is not gaining the energy, why it is not what is that one absorbing the energy? So because here what it may be, electron is revolving on that one, it is having the total two types of the forces. One is called what is that one, centrifugal force, which is work outside, and another one is the centrifugal force, which can comes inside. So one force is outside and one force is inside. So these are the centripetal and centrifugal force. First let us come to how we are getting the centrifugal force. Centrifugal force is nothing but, so generally already know that one proton is having the positive charge, electron is having the negative charge. This positive and negative, the positive and negative both are having the some attractive force. Due to that attractive force, here you are getting the some what is that one, centrifugal force. And when you come to the centrifugal force, that is equal to Ke E square by R square. The K is the constant, E is the charge of the electron, R is the radius. That it depends upon the charge of the electron, radius. If the radius is increasing, automatically the attractive force will be decreases. So like that, the centrifugal force will be equal to Ke E square by R square. Similarly, when you come to the centrifugal force, it is equal to mv square by r. It is depends upon the mass of the electron, velocity of the electron, and radius. So like that. So the electron is having the total two types of the forces. One is the centrifugal force and one is the centrifugal force. And as long as electron is revolving in the nucleus, the centrifugal force and the centrifugal force both are equal. So due to the centrifugal and centrifugal force are same, so there is no change in the energy of the electron. It is called a quantized. So that means the angular momentum of the electron will be quantized. So here you can see the angular moment of the electron is quantized in the shell. So that means what is that one? The angular momentum mvr is equal to nh by 2phi. So mvr is equal to nh by 2phi. M is the mass of the electron, v is the velocity of the electron, r is the radius. Radius is nothing but this one. And n is nothing but quantum number, that may be 1, 2, 3, 4 like that. H is the Planck's constant, and 2 and 5 both are the constants. So what you are understanding here, these orbits are called stationary orbits. As long as electron is revolving in the orbit, there is no change in the energy because their centrifugal force both are equal. Next, let us come to, according to the Bohr theory, you can find the radius of the orbit, velocity of electron and total energy of electron. The radius of the orbit will be calculated by using the R is equal to 0.53 n square by z angstroms. So R is the, what is that one? Radius. What is the radius? Radius is nothing but the distance between the nucleus and electron. So radius is nothing but this one. The distance between the nucleus and electron is called radius. That will be calculated by using the formula R is equal to 0.53 n square by z. So R is the radius of the what is that one? Atom, and n is the principal quantum number, z is the atomic number. So and this 0.5 that will come from this constant. Generally the formula is this one, R is equal to h square epsilon phi me square into n square by z. And these all are constant values. When you are substituting these all values, you will get the 0.53. So by using this formula, you can find out the radius of orbit. Similarly, you can find out the velocity of electron, the speed of the electron. To find out the velocity of the electron, we are using the formula V is equal to 2.186 into 10 power 6 Z by N. V is equal to 2.186 into 10 power 6 Z by N meter per second. Similarly, you can find out the total energy of electron also. To find out the total energy, you are using the formula minus 13.6 into Z square by N square. So Z is the atomic number, N is the principal quantum number. So in electron volts. So by using these three formulas, you can find out the radius of the orbit, velocity of electron and total energy of electron. The energy changes takes place when electron is moving from one energy level to higher energy level. So that means, for example, if electron want to move from the lower energy level to higher energy level, the energy absorption takes place. By absorbing the energy, the electron will move from the lower energy level to higher energy level. And what is the amount of the energy is absorbed? That will be equal to energy difference between these two energy levels. So E3, E2, E3 minus E2. So when this amount of energy is absorbed by this electron, then only the electron will move from this energy level to this one. So by absorbing the energy, electron will move from the lower energy level to higher energy level. And the same thing, when electron is coming back from higher energy level to lower energy level, same amount of energy will be released. That means E3 minus E2, like that. So the energy changes takes place when electron is moving from one energy level to another energy level. It is takes place by absorbing lower energy level to higher energy level, by releasing higher energy level to lower energy level. This amount of energy changes will be equal to the energy difference between these two energy levels, like so first and third, E3 minus E2. Next, let us come to limitations of Bohr model. So generally it is having the so many types of the limitations. It is not explain the Zeeman effect, and also it is not explain the Stark effect. It is not explain the uncertainty principle, and also it is not explain the spectrums of the large atoms. It is successfully explain the spectrum of the hydrogen atom, that is the one electron atoms only, and it is not able to explain the other atoms which are having the more than one electron. Thank you.